In this first chapter, we will take a look at the bokeh.plotting interface. This is a simple but flexible interface that is a good place to get started using Bokeh. This interface gives you a basic empty plot with sensible but customizable defaults for things like axes, grids, and tools. Into this plot, you can add glyphs that connect visual properties directly to your data. So what are glyphs? Glyphs are visual shapes that can be drawn on the screen. These can be simple point-like markers such as circles, squares, or triangles, or more sophisticated shapes such as rectangles, lines, patches, wedges, and others. In every case, these shapes have visual properties that can include things like position, or X and Y coordinates for locating a shape on the plot, size or radius, fill and outline colors, or transparency, also called alpha. Let's see what this looks like in typical usage. First, in order to use bokeh.plotting and also to see our results, there are some standard Python imports. Here we see from bokeh.io, import output file and show. These two functions make it easy to save the plots we make in an HTML file and open up a browser to display that file. It's also worth mentioning that we could instead import output notebook in order to display plots inline in a Jupyter Notebook. Although we will not be using Jupyter Notebooks in this course, they are very common in the world of data science. We also see from bokeh.plotting import figure. The figure function is what creates the basic empty plot with sensible defaults I mentioned earlier, and it's all that's required to get started using the bokeh.plotting interface. Next, we call the figure function with some arguments that control general properties of a plot. In this case, we have passed plot width equals 400 to specify that the overall canvas for drawing the plot should be 400 pixels wide. There's a corresponding plot height if you want to change the default canvas height. We also have passed in the argument tools equals pan, box zoom. This tools parameter can accept a list of actual tool objects, or more commonly, a comma-separated string that lists the names of built-in tools. In this case, we choose to add a tool for panning the plot region and a tool for drawing rectangular regions to zoom in on. We call the .circle method on the plot returned by figure. In this example, we pass two Python lists that represent the x and y coordinates of the circles respectively. All other visual properties, such as size, color, etc., will take on default values. Finally, we call some functions to display the results. We call output file to specify that we want to save the output to an HTML file. Then we call show, which saves the file and conveniently opens a browser to display it. What kinds of values can be attached to glyph properties? We've seen that Python lists can be passed in, but more generally, any sequence type will do. Tuples, arrays, columns from pandas data frames all work well. It's also possible to configure properties with a single fixed value. In that case, however many glyphs are actually drawn, they will all have the same value for that property. This has already happened implicitly in the previous example. We supplied lists for the x and y coordinates, but the size, color, and transparency had single default values that carried over to every circle that was actually drawn. In the example code here, we've set the x value to 10, but given lists y and for size. In the output, we can see that all the circles are centered at x equals 10, but that the y values and sizes vary according to the lists that we passed in. The first set of exercises will give us practice with marker-like glyphs. We will use circles throughout, but I should mention that Bokeh comes with many standard marker shapes built in. Here's a list of all the built-in markers. In addition to marker-like glyphs such as circles or squares, Bokeh can draw many other kinds of visual shapes. Let's take a look at some of them. Lines are a graphical component that is important in many different situations. With Bokeh, lines are created using the .line method in exactly the same way that we saw in the last section. Now, instead of drawing circles or other markers at the x and y coordinates, a line is drawn through those coordinates. If you'd like to have markers and lines together, Bokeh makes it simple to combine multiple glyphs on one plot. Simply call more than one glyph method. All the glyphs that you specify will be drawn in the order of the glyph methods that you call. In the example here, we see that .line has been called first, and then next .circle has been called with fill color equals white. Accordingly, we see a line with filled circles drawn on top. In this case, we use the same data values for both glyphs, but that is not required. Any combination of glyphs using any combination of data as inputs will always work. Another useful glyph is patches. Patches can be used to draw multiple polygonal shapes at once on a single plot. This might be useful if you want to draw geographic regions such as countries or states. The input data for patches takes a slightly different form, which is worth looking into. Just like Circle can draw multiple circles by being provided a list of coordinates, Dot patches can draw multiple polygons by being given a list of patch coordinates, but each patch itself needs multiple coordinates. For this reason, the coordinate data for dot patches is a list of lists. One list of lists is for the x coordinates, the other for the y coordinates. Each sublist contains the x or y coordinates for one patch, and the corresponding sublist for each individual patch must match in length. In the example here, we can see the lists xs and ys, which are both of length 3. This data corresponds to the 3 patches being drawn, but each of the 3 items in the list is another list, with all of the x coordinates or y coordinates for one of the 3 patches. It's only the coordinates that are nested in this way. If we want to shade each of the 3 patches from the previous slide in a different color, we can pass, for instance, fill color equals red, blue, green, a list of 3 colors because there are 3 patches. Although we won't practice with them directly in this course, I also wanted to mention there are other glyphs that are available in Bokeh. Glyphs like wedge, annular wedge, rect, v-bar, h-bar, and others can be used to create extremely versatile visualizations for all kinds of data. For more information, see bokeh.pydata.org. Now that we have some practice using basic glyph methods, let's take a closer look at what kinds of data formats can be easily used to drive glyph properties. We have already seen that standard Python lists work just fine and can be passed as a value for any glyph property. Another common possibility is NumPy arrays. NumPy is a Python library for dealing with multi-dimensional arrays of data efficiently. It is the foundation of the scientific Python stack, and many of the powerful Python packages for analytics and data science rely on it directly or indirectly. Here we use the NumPy function linspace to create an array of 1,000 values evenly spaced between 0 and 10. These will be our x values. Then we use the NumPy sine and random functions to compute a noisy sine curve based on those x values. Just like with Python lists, these NumPy arrays can be passed directly to the line glyph method to specify the x and y coordinates. Another common Python library for data science is Pandas. Pandas provides a data frame structure analogous to the R data frame. It's efficient for working with tabular sets and time series. A Pandas data frame is comprised of several columns, each with a unique name. These columns in a data frame are accessed using square brackets similar to a Python dictionary. As it happens, the underlying implementation of Pandas columns uses NumPy arrays, so passing Pandas data frame columns works exactly as you would expect. In this example, we have loaded the flowers dataset, which contains measurements of 3 different species of iris flowers as a Pandas data frame. We can show a scatter plot of petal length versus sepal length by passing the columns for petal length and sepal length to the circle function. Now it's time to talk about a data structure that is central to Bokeh, the column data source. This data structure is used extensively in Bokeh. It is what takes care of getting your data from Python to the final JavaScript and HTML document that is displayed to users. Essentially, it's a stripped-down, simpler version of a data frame. It has a .data attribute that is a Python dictionary which maps string names to sequences of data. Column data sources are often created for you, and in all the examples we have seen so far, this has been the case. When you pass in x equals list123 to the circle method, Bokeh creates a column data source for you behind the scenes and maps the name x to the list 123. But there are times when it can be useful to create or use column data sources directly. For instance, column data sources can be shared between glyphs, and this enables selections between plots to be automatically linked together. We will see more about this in Chapter 2. It's also possible to add extra columns to column data sources that can be displayed in hover tooltips or used by other tools. We will come back to this in Chapter 2 as well. Let's take a quick look at the details of column data sources. First, note that to use them directly, we must import column data source from bokeh.models. Then we can create an instance of column data source by passing a data dictionary to the initializer. This dictionary should have string keys and sequences, such as arrays or lists, as the values. It is very important to note, all the columns in a column data source must be the same length. The last thing to mention about column data sources is that they are easy to create directly from Pandas data frames. Here we have imported the flowers dataset from bokeh.sampledata.iris. The data is stored in a Pandas data frame, which we examine with the .head method. To create a column data source from this data frame, we simply pass the data frame to the column data source initializer. Now the data source can be passed to any glyph method. As mentioned earlier, the iris dataset has various measurements of flowers for 3 different iris species. It is a common dataset used in demonstrations, and we will return to this dataset again in later examples.